Hello everyone, this is Poornima Deepthi working as an assistant professor in the Department of ECE, MLR IT, Hyderabad. So this is the series of videos of the microprocessor and microcontroller. If anyone didn't watch the previous video, please watch that previous video because there is a basics of a microprocessor. Without knowing the basics of microprocessor, you will not understand the concept of microprocessors and how they have been evolved in these years. So in this video, I'm gonna explain what are the basic building blocks of microprocessor and how these microprocessors have been evolved. So this is the basic functional block diagram of microprocessors. As in the previous video, I have already discussed what is a microprocessor and how microprocessor use it in nowadays. Okay. So let us dive into the basics of microprocessor, block diagram of microprocessor. In the basic block diagram of microprocessor, these are the units which will be presented. First one, ALU, arithmetic and logical unit. It will perform all the arithmetic operations and logical operations. As many of you know that what are the arithmetical operations: addition, subtraction, division, multiplication, modulus, all this comes under the arithmetic operations. And what are the logical operations? And performing AND, OR, NOR, XOR, all this comes under the logical operations. In microprocessor, these arithmetical logical operations are always done with the help of arithmetical and logical unit. Okay, and next coming to the register array and internal memory. So basically the microprocessor which we are using 8086 which we are going to learn doesn't have any memory, but there should always be some memory to support that microprocessor, that we are taking the memory outside the as a external device. So here register arrays are used. What are the registers? Registers are the devices which is used to store the immediate values. Like if we are performing any arithmetical operation, that arithmetical operation you should take the input and you should store it in any one of the devices. That input should always be stored in the registers which we have using normal general purpose registers. AX, PX, CX and DX will be there in the 8086. Apart from these general purpose registers, there are many special function registers. Always these registers are of 16-bit because 8086 is a 16-bit microprocessor. So what are the flag registers? With these register arrays, there will be always the flag register. Flag register is also one of the 16-bit register which is used to store the status of the operations which we have performed or status of the microprocessor. So here instruction and decoding unit, as I already told you that how a processor is used to execute an instruction. It always fetch the instruction, decode the instruction and execute the instruction. To decode that, there will be a one unit which is nothing but decoding unit. And here timing and control unit. So as what is a timing and control unit? Timing and control unit is used to control the microprocessor. So how it will control the microprocessor? Let us take an example. So if we are storing one data in memory, so 25 is the data is stored in the memory. Okay, so if I want to replace this data with the data 35, so this 25 data which is present in one unique address, let us give this unique address is 1234, and using this unique address we can identify the data in the particular memory. So every location in memory will always have a unique ID, unique address to find the data present in that memory. So I want to replace this data 25 with data 35. How I will replace? First, we need to fetch the information present in the first. You need to identify the address. You need to note the address. So using address bus, you could find the address of that particular memory. And now we need to insert 35 number into the memory location, which already there is a number like 25. You need to replace this 25 number with 35. This is, if we are considering this is a memory, there will one number will be present, one data present in that memory having the address of 1235. So to to insert other number like 35, we need to insert this 35 into this particular, instead of 25, I want to replace the data with 35. So how it will be executed by the microprocessor? First, the microprocessor always fetch the address of that particular number, and that you need to insert 35 into that particular number, which is nothing but the write operation. So when we are inserting any data into the memory, that is the write operation. When we are fetching the memory data from the memory, it would be the read operation. Okay, so these are the control operations. These are the basic control signals which we are using in the microprocessor. So control bus is used to send the signals that we are writing the data or we are reading the data from the memory. So these are the control signals. So these control unit is responsible to send these control signals by using the control bus, and address bus is used to identify the address, to transfer the address, and program counter and instruction pointer is a 16-bit register which is used to hold the address of that particular program. Okay, these are the basic building blocks present in the microprocessor. Now we are going to how these microprocessors have been evolved. So basically, in the early 1900s, these vacuum tubes came to the picture. So these vacuum tubes are the basic electronic devices that can control the flow of electricity, and is composed of glass-like elements. See, glass tubes with electrodes at both ends. These are the key components of the computer that are having several limitations. That it's a very heavy in size, bulky in size, they are fragile, it consumes lot of power. So to avoid these limitations, they, after years of experiments, in 1947, William Shockley, John Braden, and Walter Brattain invented a transistor, which have been using in nowadays also in microprocessors also. Transistors are very small, much smaller when compared to the vacuum tubes, and they are much more reliable, and it consumes far less power when compared to the vacuum tubes. They have been quickly replaced by the vacuum tubes in many computers. So next, there come to the picture of integrated chips. The microprocessors which we have using nowadays will always be in the format of ICs, integrated chips. So these integrated chips are invented in the year 1961, commercially available in, it is also a semiconductor chips which many semiconductor components can be integrated in a single chip. All these computers now started using these integrated chips. So now coming to what are the generations of microprocessors? Actually, there are 5 generations of microprocessors, and what is the first generation of microprocessor? The first generation of microprocessor came into the picture in 1971 to 1972. So basically, it is the 4-bit microprocessor which is invented by the Intel Corporation in 1971. So this is the 4-bit microprocessor. So what is a 4-bit microprocessor? 4-bit microprocessor means it can perform 4-bit operations in a clock pulse or a single time. So now, what is a clock pulse? So what is a clock and what is clock pulse? Clock pulse will be like this. This is the complete one clock pulse. So if we consider clock as a heart of a human being, then clock pulse is the heartbeats which keep synchronizing between the parts of the body. Like if clock is a generator which generates the clock pulses to synchronize the blocks present in that system. So at a clock pulse, 4-bit arithmetical or any operations can be performed at a time, is nothing but the data bus. We can say this data also, data lines. How many data lines? If the microprocessor is having 4-bit data lines, then it can execute 4-bit data at a time. So these microprocessors are the primary microprocessors as the first generation microprocessors. Basically, it is used in the calculations or calculators, simple mathematical calculations. Simple mathematical calculations. So this is the first microprocessor invented in the year of 1971 by Intel Corporation. C4004. This microprocessor is having the clock speed of 740 kilohertz and consists of 2300 transistors. This single chip consists of 2300 transistors and it can execute 60,000 instructions per second. Basically, in this microprocessor, there are only 42 instructions are there. 42 instruction set is there. So next, coming to the second generation of microprocessor. These microprocessors, second generation of microprocessors are basically 8-bit microprocessors. Starting from the year of 1972, the generation ends at the year of 1978. These processors, along with Intel, there is Motorola 6800 and 6801 have been came into the existence. These second generation microprocessors are defined by the overlapped fetch, decode and execute. So basically, in the first generation microprocessors, at a time it is a serial format. How instructions will execute? First it will fetch the instruction, next it will decode the instruction, and then it will execute the instruction. This is always done in serial format. We're coming to the second generation microprocessors. This fetch, decode, execution will be the overlapped fetch. Means at first clock cycle, the first instruction will be executed. First instruction will be fetched. And for second clock cycle, the first instruction will come to the decoding stage, but as well as the second instruction will be fetched. For the third clock cycle, the first instruction will be come to the execution stage and the second instruction will be coming to the decoding stage and the third instruction will start fetching. So this is the overlapped fetch, decode and executing the steps. Intel 8080 is the first 8-bit microprocessor. This is the Intel 8080 is the first 8-bit microprocessor which is having 40 dual inline package. 40 pins will be there for different input and output purposes. So next, the result of this technology have increased speed, execution and higher chip densities. Okay, 8-bit microprocessors are 8008, 8080 and 8085. This is the first commercially successful microprocessor. 8085 is the first commercially successful microprocessor. And these microprocessors, the second generation microprocessors, had a wide application but it's have been using in the computers. The gaming consoles came into picture, and some of the microprocessors like microcontrollers have been using in the microwave and washing machines. So next, these are the 8008 microprocessor, 8080 and 8085 microprocessor. All are 40-pin microprocessors. 8008 has invented in the year 1972, which is having the 500 kilohertz clock speed, and number of transistors used in that particular chip is 3500. See, the number of transistors have been using in the ICs are very increased in time. And how many instructions? In 8008, 50,000 instructions can be executed per second. And this has been 10 times become fast in the 8080. And in 8085, it is a commercially successful microprocessor which is having 8 bits. 8 bits, but the address lines are 16-bit. I will be discussing this in the next further classes. So it is having 3 megahertz and transistors have been using is 6500. So next, coming to the third generation microprocessors. Another benchmark of Intel have been in this generation, which is 286. From this generation, there is a human race change of in the video gaming, taking videos, pictures, all these things. From this generation started from 1979 and it have been ended in the 1980s. Basically, third generation microprocessors are always the 16-bit microprocessors. Here, the best example of another commercially successful microprocessor 8086 and 80286 is another benchmark of Intel Corporation. So these are basically used in personal computers, in you can say that microcomputers also, and industrial automation has been done in this third generation only. So coming to the third generation microprocessors, the first third generation microprocessor is 8086 microprocessor. It is a 16-bit microprocessor and it is having 20 bits address bus. And it has a wide range of clock of 4.77 megahertz to 10 megahertz. There is a 3 versions of clock speed in this microprocessor, and almost 29,000 of transistors have been used to manufacturing this 8086 microprocessor, and 2.5 million instructions can be executed in 1 second. Another benchmark is 80286, which has been introduced in the year of 1982 by using 8 megahertz of clock, and 134,000 transistors have been used to manufacture this 80286 processors. So next, coming to the fourth generation microprocessors. This microprocessor era continued in the 1981 to 1995. So basically these are 13-bit microprocessors which can perform 13 bits of operations at a time, at a single clock time. Along with Intel 80386, there is a Motorola which have been introduced the 68020 microprocessor, very popular microprocessors. And the main thing in this fourth generation is the microprocessors are introducing the RISC architecture, reduced instruction set computer. RISC architecture, reduced instruction set architecture have been using in this fourth generation microprocessor. In this generation of microprocessors, there is a huge, humongous advantages by using it is served in the servers and multimedia. Graphics have been introduced, video games came into picture in this fourth generation microprocessors. And these microprocessors are 80386, 80486. Another benchmark of process, Pentium processors have been came into the picture in the year 1993, which is a humongous change in the microprocessors. So it is using 66 megahertz of, this is the first microprocessor which is having the cache memory of 8 bits for 8 bit of instruction of data. So now, fifth generation microprocessor, which from 1995 until now we have been in this generation of microprocessors. Nowadays we are seeing i5 microprocessors. If we want to buy some system or computer, we will select which processor we need to have. So there is a humongous processors using nowadays, i5, i7, and if you know about the AMD processors, we have been using this type of processors in nowadays. This is the fifth generation of microprocessors. And as you all know that by using this microprocessors, there is a artificial intelligence and self-driving cars. There is humongous applications of this microprocessors. And these fifth generation microprocessors are of 64-bit processors, which is having Pentium processors, I-Core, Intel Cores 5th generation, Intel Core 7th generation, Octa, Celeron, Dual, Quad, and Octa Core came into existence in this 5th generation microprocessors. And in i3, i5, i7, these are the processors introduced in the year 2007, 2009, and 2010. Respectively. So, what are the, until now we have discussed about the basic building blocks, which is present in the microprocessor. I will represent microprocessor as MUP, microprocessor. and what are the how microprocessors have been evaluated came into picture by using vacuum tubes until 5th generation of microprocessors. So in upcoming video, I would like to explain what are the features of 8085 and how 8086 came into the picture after 8085 and the architecture of 8086. Thank you.